Mixtures, properties, and separation. So the syllabus has this here. So it says recognize that materials are either pure substances with obviously their own properties. There's a list of a few there, or mixtures with properties dependent on the density of relative amounts of substances that make up the mixture. So mixtures will have two or more different materials, and they'll retain properties that are a mix between those two different materials that makes up the mixture, two or more. So the Pearson textbook barely gives a page to this. The Oxford textbook tries to kind of cover everything in a very short distance, just give a smattering. So I think the best way to go about it is just to give you an idea of how to deal with the random question. So first of all, we'll look at boiling point elevation. So if you look here, I've just given you a few common ones. So boiling point elevation, basically adding substances to water, basically. So if you add a non-volatile substance to water, you will find that water will increase in its boiling point. And so often it's salt. This one here is sugar. And because it's non-volatile, it actually makes the boiling point increase. If you just jump down and add a volatile mixture such as ethanol that has a lower boiling point, you'll see that when you add that, add more and more ethanol there, you'll find that the boiling point will get lower and lower, and you'll see that 373, that's 100 degrees Celsius, 373 Kelvin. So it goes from the boiling point of water when it's pure to the boiling point of ethanol when it's pure, like 78 degrees Celsius, and anything in between is a curve in between, and you don't quite know what that curve's going to be unless you think very carefully about it. It's probably too hard for ATAR. But it would be quite good as an SE, I think. Okay, so let's just go back up to the non-volatile substance. So adding a non-volatile substance, you're going to increase the boiling point. That's because water will be attracted. The water molecules will be attracted to those molecules, and also because those molecules will also cover the surface in some sense too, to lower boiling point and evaporation. Okay, so water molecules have difficulty changing to the vapor states. They're attracted to the solute, and the solute blocks escape from the surface. That's especially true of salts because they're quite small, strong ions, and the water just latches onto those because they're quite positive and negative, whereas water just has hydrogen bonds. So that's called boiling point elevation. Something slightly similar is freezing point depression. And so water, in order to freeze, forms these crystals. And so that's quite unique to water in that it has a lower density when it's colder. So you can see all of these chemicals have very specific properties, and they'll interact in quite unusual ways as well. And so the salts getting in between those will make it far more difficult for the water to organize itself into these crystals. So that is why adding substances, non-volatile substances to water will decrease their freezing point. So they use that to melt snow. They just throw salt on the roads, the icy roads, and that melts the water and gets rid of the water. Boiling point depression, adding salt to the water when you cook food raises the boiling point, so your food cooks quicker. Okay, that's just one of many applications of these things. And so the mixture here, another. I've already talked about this one, but another sort of curiosity here is if you put 500 mils of water with 500 mils of ethanol together, the volume will not be 1 litre due to the interactions of the two molecules. So the molecules will become more dense because the smaller water molecules will fit in between the ethanol molecules, and it'll be less than 1 litre. So it's very hard to judge. There's so many complicated interactions depending on which two chemicals you put together, and so just be aware of that. Finally, they have also mentioned how to separate these things, and so I've just picked the ones that have good chemistry concepts in them. So distillation and the ones that may come up again in organic chem or other places in your syllabus. So this one's a good one. So the ethanol will boil off first at around 78 degrees Celsius. This has got cold water running in this way. Okay, and this is called countercurrent. It's used in fish gills because it's a far more efficient way to exchange oxygen. So it's used in biology, it's used in physics for heat exchange, and this is technically physics, I guess. This is chemistry though. So this is countercurrent heat exchange. It's far more efficient to have the cold water going this way rather than the cold water running this way. So that's just a little bit of extra if you're interested. And so that will cool it down below 78 degrees and it'll condense out. And once that all the alcohols come off, you'll see this gradually rise and hit 100 degrees Celsius when you've only got water left. So distillation is a common way to separate materials based on boiling point. Some other common ways to separate materials. Chromatography has its own video. That one is separated by solubility in this example here, but you can separate. Chromatography is fantastic because there's a whole different types of physical and chemical properties you can use to separate substances out, and a whole heap of techniques that have different setups to this. Just because you'll also be using this one quite a lot, filtering, separating by particle size. The filter paper will have various sizes, pore sizes that you can look up. And centrifuging, I'm staying away from the physics here, centrifugal force versus centrifugal force. Let your physics teacher talk about that, but basically you spin it around and the heavier stuff goes to the bottom, and so you're separating by molecular weight. So if you're lucky, your school will have a centrifuge, and again that's more of a biology thing where they separate blood out by its different components, but it has many other applications. Okay, so that is a quick overview of the complexity of mixtures, the different compounds there are, and the different effects they have on each other, and various separation techniques.